All right, looking at proof number 6. I have line AB is perpendicular to EF. I have CD is perpendicular to EF. Then what we want to prove, and I'm wondering if this needs an if. This is true, so this is considered as our given. Then measure of angle 1 is equal to measure of angle 2, and then this is what I'm to be proving. All right, so let's go ahead and get that given stated in there. Line AB is perpendicular to line EF. Line CD is perpendicular to line EF. So that's what we've been given. So let's talk about what that means. When I have two lines that are perpendicular, by definition, isn't that going to mean that they intersect at right angles? If they intersect at right angles, then when I'm talking about the measures of angles 1 and 2, can I say that they're right angles? So we're going to have to be really precise here with our definitions. So we'll go ahead and say we're given that the lines are perpendicular. So we're going to say that angle 1 is a right angle. And guess what? Angle 2 is a right angle. And those together are going to go with my definition of perpendicular lines. So if you go back to that definition in Unit 1, it says if two lines intersect, or if two perpendicular lines intersect, then they intersect at a right angle. So that helps us with that. All right, so then we're going to go ahead and say the measure of angle 1 is going to be equal to 90 degrees, and the measure of angle 2 is equal to 90 degrees. And of course, we know this because, how do we know that? Because that is my definition of a right angle. If I'm going to take the time to say it's a right angle, then I got to say, oh, by the way, the measurement of a right angle is 90 degrees. So now that I have these two equal to each other, I can say that the measure of angle 1 is equal to the measure of angle 2. And I can say that I substituted this in for that. Or if you wanted to use your 90 degrees as your link, that's fine. Whether you call that the transitive property of equality or the substitution property of equality, they're both the same. In this case, not always, but in this case they are. All right, that was a quick one, right? One left to go.